Hello, everyone. Today we are continuing with sound. This section in particular focuses on sound intensity or volume. Okay. Now, it starts us off with a prompt asking three ways you can reduce the loudness of a sound heard by an individual. Okay. The most obvious answer is to, just decrease the volume on either the phone or the speaker or wherever the sound is coming from. Okay. Now, what I want you to think about is this: when you increase or decrease the volume on your phone or your speaker, are you actually increasing or decreasing the volume? No. What you're increasing or decreasing is the power output. Okay. You're decreasing and increasing the power output. Okay. For example, you can lower the volume on your phone, but bring the phone closer to your ear so that it still sounds like it's the same volume to you. Okay. So more things go into volume than just whatever setting you have on your phone or on your speaker. There are some things you can adjust. Okay. And that's what we're going to talk about. What goes into that. Okay. So again, sound is just waves vibrating and going through the air. Okay. How fast they travel through the air is what plays a part in how loud something is to us. Okay. That rate of energy transfer from the vibrations to our ears, that's what we call power. That's what the definition of power is. Power is energy over time. It's how much energy you put into something over a given amount of time. That's what determines power. Okay. So here is the equation to determine the intensity of a sound. So when we say volume, what we're really talking about is intensity, is how intense the sound is to our ears. Okay. And it's includes power and radius, where radius is how far you are from the sound source. Okay. So let's explain power. P is power. How much energy is going into the wave? So speakers are powered by electricity, right? We can increase how much energy we give the speaker. We can decrease how much energy we give the speaker. And that adjusts the power output, okay? The higher or the more energy we give it, the louder it can be perceived to be, assuming we are standing in the same spot, okay? Underneath the equation, or in the denominator, you have radius, or the distance from the source. And notice that power is not squared, but distance is. Okay. That means distance plays a bigger part in how loud something is to us more than power does. Okay. So, for example, let's say you wanted to, again, with the phone, you lower the volume on a phone because let's say you're in a room, you enter a room, it's a public room, you don't want people to hear your music, but you want to keep listening to your music. So you lower the volume, or you click on the button to lower the volume. You're really just lowering the energy. And then you bring the phone closer to your ear. That way you can get the same intensity. You get the exact same intensity with a lower power. Okay, that's also how you save, electricity as well. Okay, you can lower power and also lower distance. You can lower both and you can still have the same intensity. Okay, so how loud something is perceived is controlled by how much energy we put into it and how far it is from the source. That's how we adjust that. Okay. So back to the original prompt, name three ways you can reduce the loudness of music heard by a person. You can do the obvious thing, which is lower the power output. Okay. Or you can move the speakers. Okay. You can move the speakers closer to let's say at a concert, you can move the speaker closer to the people. You can move the speaker further away from the people. Okay. All depends on how loud you want it to be. You can also adjust the angles of the speaker. That's another thing you can do to change how loud things may be. Because remember, sounds can combine to get louder. They can also combine to get quieter. Okay. So that's another thing you can do. Okay. Intensity is measured in decibels. So on volume, if you look at a speaker, the knob that controls volume, you'll see a little unit that says dB. Okay. dB is decibels, and this is how we measure volume or intensity. Okay, that's how we scale it up. So intensity, here is a table of intensity. So here we came up with these numbers, right? And then to make it easier to understand, what we did is we came up with a system, we scaled it down to decibels. Okay, so this intensity, 1 times 10 to the negative 12, we call that 0 decibels. Okay, to make it simple. This is the quietest sound that we can hear. Okay, this is the quietest that we can hear. Any intensity lower than that, and it is too quiet for us to listen to. It is too quiet. We won't hear it. Okay, we will not hear it. Okay, so now we're getting into the units. This table gives you reference points. So now at 10 decibels, that's like leaves blowing, on the ground, the wind blows some leaves, the leaves that you hear, that's 10 decibels. Okay. Someone whispering to you, a very quiet whisper, is like 20 decibels. Mosquitoes at 40, a regular conversation back and forth between normal people, that's at 50. Okay, now you start getting into machinery. Vacuum cleaners are at about 70, lawnmowers are at 90. Okay, once you start getting to the 120, this is the cutoff point. Okay, this is where now we start getting into injuries. Okay, anything louder than a $120 and we start getting hurt. Okay, so what's above 120? Thunder. Okay, thunder, machine guns. I don't know if any of you guys ever been to a gun range, but there's a reason that everybody in the gun range is wearing hearing protection. Okay, hearing protection, ear protection. Okay, the earmuffs. You need that. Okay, you will go deaf if you don't. Okay, jet planes. If you stand next to a jet plane when it's taking off, you can blow your eardrums out. Okay, if you're too close to the source of thunder, that can blow your eardrums out. Okay, so this is just to give you an idea, to give you some reference points. Okay, so 0 decibels, just to make it simple, 0 is the quietest that we can hear. Okay, so you can technically hear something at 0, but barely. Depends how good your hearing is. Okay, and then 120 is the maximum. Anything higher than 120, and you start damaging your ear. Now, intensity is not the same thing as frequency and wavelength. Okay, this has nothing to do with pitch. This has nothing to do with how high the sound is or how deep or low the sound is. This is strictly volume intensity. It has nothing to do with the frequency, has nothing to do with the wavelength. Okay, so that's intensity. This is the equation. Okay, remember it pertains to power, how much energy is in the wave, and how far we are from the source. Okay, that's all intensity is. Okay, and then this is a little graph that gives you a nice little region. So this graph has an intensity chart and it has a frequency chart. This is where most people talk. Okay, so the speech region that they're referring to, that's is just where most human conversation takes place. Okay, notice the range in frequencies. Some people have deep voices, some people have high-pitched voices. You guys all know that. Okay, and they give you different ranges of music and things like that. And then up here is threshold. Okay, so most people don't speak in volumes that are that high to cause pain, but other things can. And then obviously most people don't speak that quietly to where we can't hear anything. Okay, so this is just a little graph representative of all that. Okay. Now then you have things like forced vibrations. Okay, so this is now we're getting into the world of musical instruments. Okay, so pianos, guitars, wind instruments, all these things produce vibrations that make a harmonic sound. Okay, but energy has to be transferred from one component to the next. Okay, and you end up getting these things called resonance. Okay, give me one moment. Someone is at the door. Okay, my apologies. I am back. Okay, so and so now we're in the world of, I'm sorry, forced vibrations and resonance. That's where we were on resonance. So what is resonance? So when we talk about musical instruments, again, you pluck on strings and blow into windpipes and things like that. to get your sound. You produce sound. What can happen is that depending on the instrument and where you are, you can get this thing called resonance. Okay. What resonance is it causes other things to join in on those vibrations. Okay. So let's say you pluck a string on the piano, or not. Well, pianos do have strings in the back. Okay. Let's say you pluck a string on a guitar and it vibrates, and you only plucked one string, but that one vibration causes the other strings to vibrate as well, even though you didn't touch them. How does that happen? Well, everything has something called a resonance frequency. Okay. So here we have a quick little demo. So there's a guy singing into glass cups and they can shatter. Okay. I'm sure you guys have seen that before. That's caused by resonance waves. Everything has a resonance frequency. And what that means is if you produce a sound that matches the resonance frequency of another object, then that other object will join in on the vibrations. Okay. So, it doesn't matter how far it is. So, let's say again with the guitar, you pluck a string on the guitar, and let's say there's another guitar across the room. If that string is vibrating at a frequency that matches the resonance frequency on one of the strings on the other guitar, it'll start to vibrate as well. And that actually goes for absolutely anything. Okay. And they're actually using that kind of technology in different things like the medical field. Okay. So, if, for example, your speakers, your monitors, your phones, the human body, everything has a resonance frequency. And if you can make a sound that matches the resonance frequency of something else, it can vibrate violently. And depending on what it is, it can shatter. In the case of this video, you have glass shattering. It vibrates violently and so fast to the point where it can't handle it and it can break. Okay. And you can use it to your advantage depending on what you're trying to do. Again, they're using it now in the medical field. Okay. But that's what resonance is. This term resonance, that's what they're talking about. Okay. That's what they're talking about. This can also cause major issues in structures. Okay. So, bridges. Here they give you the example of bridges. Let's say you build a bridge, you build a structure, any kind of structure. Eventually, there's normal wear and tear, but some things can cause more wear and tear than others. Okay. If sounds are produced, and sounds are produced all the time with all different types of frequencies, cars driving, wind blowing, animals, like everything. If it just so happens that a loud enough sound is made that matches the frequency, the resonance frequency specifically of the bridge, it can cause the bridge to collapse. So you can weaponize these things as well. Okay. It sounds like science fiction, it sounds like hocus pocus, but if you can design a speaker to match the resonance frequency of anything that you want, you can destroy things easily. Okay. If you made a loud enough speaker and just put it in front of a building and it produced a sound that matched the resonance frequency of the building, you can destroy it. Okay. That's why resonance plays such an important role in certain things. Okay. You can weaponize it. You can do a bunch of things with it. Okay. But that's what us all resonance is. Everything has a resonance frequency. If you match the resonance frequency, it'll vibrate. Okay, that's all it is. Okay, and that is the end of this section. How we're doing on time? But not too long. Okay, we're at the 15, almost at the 15-minute mark. Okay, so quick summary. Let's see if we can summarize this really quickly. So again, this section is focused on intensity of sound. Intensity of sound is affected by how much power we give the sound and how far we are from it. Okay. You can increase or decrease the energy you give it on a speaker with the knob, and how far or how close you are will affect how loud it is to your ear. Okay. how we determine or measure that, we use it by decibels, okay? 0 is the lowest that we can hear. A buck 20 is the loudest before it starts to hurt. Anything above that, you get pain. And you have these reference points for you to give you an idea, okay? And then we get into the world of resonance. Resonance just has to do with the frequencies of different objects. Everything has a specific resonance frequency. And if you can match it, then you can make those things vibrate as well without ever having to touch them. Okay. That is the gist of today. Okay. That is all I need you to understand. Okay. Intensity is affected by power and distance and resonance. Okay. Those are the two things I need you to understand. Okay. That's it for today. As far as work is concerned, you have a brief worksheet. There are 3 questions total that you need to answer with the table above. The table gives you a reference point. This table is the same as the one in the slide here, which gives you, oh, that's the next section. It's the same as the table here, which matches intensities and decibel levels. And you also need the power equation, well, not the power equation, the intensity equation to answer the questions, okay? This I equals P over 4 pi R squared, okay? So I'll do, see if I can do 1A with you. While practicing his instrument at home, a young drummer produced sounds with 0.5 watts of power, okay? Assume the sound waves spread spherically with no absorption in the medium. What is the intensity of the sound waves that reach the walls of his room from 2 to 4 meters from the drum? Okay. So what they're asking you is how far, or from this distance, from 2 to 4, how loud was the sound to this individual? That's what they're asking you. Okay. Give me one moment. I have to take care of something for my mother. Okay, I'm back. Okay. So you know how much power the sound has, and we know how far we are. Okay, just plug into the equation. Okay, the equation is I is equal to P over 4 pi R squared. Okay, so all we need to do is plug these things into the equation. You have 2 numbers to plug in. They're asking you for a range. It says, what is the intensity of the sound that reached the walls of his room 2 to 4 meters from the drum? Okay, so what you're going to do is you're going to plug in 2 into the bottom and 0.5 up top. It's 0.5 watts. Okay, so you plug in 0.5 up top and you plug in the 2 for the R. Plug that in, you get your number for I. Okay, and then you do the same thing, but instead of plugging in a 2 here, you plug in a 4. And that'll give you your range, and you'll have an intensity from 2 meters to 4 meters. Okay. And then B, they ask you, now you're in a different room. It goes from 8 to 12. Do the same thing, just change the numbers. And then C, same thing, just change the number. Okay. So you're just plugging the numbers into that equation. Okay. I'm going to leave that up to you. Okay. But that's it for today, guys. Happy Friday. I hope all is well with all of you. Take care, and I will see you Monday.